this next example is about this pendulum here. So make sure before you watch each of these slides, you've tried these examples on your own. So in this case, we have a pendulum of length L with a bob of mass M swings back and forth. At the low point of its motion point Q here, the tension in the string is 3/2 mg, basically 3/2 force of gravity. What is the speed of the bob at this point? So again, the first thing we do in this case is draw a free body diagram. So at this point, the tension due to the string is pointing upward, and then the force of gravity points down, and we do the sum of the forces. Recall from the last example that we take the radial direction to point to the center of the circle. So the radial direction is pointing to the center of this circle, that circular path that the pendulum swings through. So the sum of the forces in the radial direction, starting here, tension points to the center, so that's a positive T. Force of gravity points outward, so minus Fg equals ma centripetal. So, and the centripetal acceleration again is v squared over r. But v squared over r, for r, we're plugging in L because in the problem they tell us that the pendulum has some length L. So that length would just be this length along here, which corresponds to the radius of the circular path that the pendulum is swinging through. And then basically plugging in the fact that the tension at this point is 3/2 mg. So we've plugged that in here, and then solve for velocity. So we can combine these terms to get 1/2 mgl, and then masses cancel out. And solving for v, we basically get the following expression.